Okay, so today we're going to move on to the next topic in solutions, which is mixing solutions. So this is still a type of calculation, and it really bases on our understanding of how to calculate concentration, which we did in a couple lessons ago. So in some cases, two solutions with the same solute are mixed, and the resulting concentration is different from the concentrations of the two solutions. So let's just take a scenario here and we're going to draw it out and just see what exactly is going on. So let's say we have a 1 liter, 0.5 mole per liter sodium chloride solution, and we're going to mix that with another 1 liter solution of sodium chloride, but this one has a concentration of 1 mole per liter. So the key here is they have to be the same type of solution, meaning it has to be the same solute dissolved. So in this case, they're both sodium chloride solutions, but they have different concentrations. So what happens if we mix those two together? What do we end up with? So let's draw this out. So here we have a beaker. Okay, so I'm going to just put over here V1. This is a 1 liter beaker, and in it, it's sodium chloride, and we'll call this concentration 1. We were told is 0.5 moles per liter. Okay, and we're going to add that to a second beaker. So it also has a volume of 1 liter, so let's try and draw it about the same size. Okay, but this one's concentration, we'll call it C2, is 1 mole per liter. Okay, so basically what I'm going to do is I'm going to take these two 1 liter beakers and I'm going to dump them into a bigger beaker. Try and show that this one's bigger. And I want to know what's the resulting concentration when I add these two things all together into a larger beaker. Now, you might be able to predict this, what the concentration would be in this beaker, because we have equal amounts. We have 1 liter and 1 liter. So you could probably predict what that is. But we don't always have equal amounts. So what you'd want to do is you'd want to figure out how many moles of sodium chloride are in each beaker. Because you have to remember that we can use, in order to figure out concentration, we would use concentration is moles divided by volume. So we know when we dump these two beakers together, we're going to have a total volume of 2 liters, right? This is going to be 2 liters in total. And if we want to figure out its concentration, we need to know what's the total number of moles of sodium chloride in this beaker. So how many moles are in each beaker, and then we can add them together to figure out how much is in the big beaker. So I'm going to say, if we rearrange this C equals N over V to solve for N, it's N equals CV. So let's just go N1 equals C1 times V1, right? So I'm going to take the concentration times the volume, and that's going to give me 0.5 moles. So there's 0.5 moles of sodium chloride in this beaker. In this beaker, I'm going to do the same thing, but with C2 and V2. So I've got 1 and 1, which equals 1. Okay, so I'm going to add those two together. So I'm going to say in total, I've got 1.5 moles of NaCl. Cl in here. And it's a 2 liter, full 2 liter solution. So what I can do then is I can say C final, once I've added those two together, is going to be N over V. Well, I have 1.5 moles in that beaker, and I have 2.5 liters of solution. So when I divide those, I get 0.75 moles per liter. Okay, so the concentration in this beaker, once I've added these two solutions together, is neither this concentration nor this one. It's actually exactly in between. Now, that's not always going to happen. The reason that happens here is because we had equal amounts of each solution, right? We had 1 liter and 1 liter. So when you add them together, you're basically getting the average of the two concentrations, but you'll see that we don't usually have equal volumes. Okay, so how can we streamline this process to make it a little simpler and easier to calculate? So really what we did, this is what we did here. We found the final concentration by calculating the number of moles in each beaker, right? I took C1 times V1 to get this number of moles. I took C2 times V2 to get this number of moles, and then I added them together. So what this represents here is the number of moles in the first solution added to the number of moles in the second solution. And what I did then was I divided it by the total volume. And the total volume is the volume in the first beaker added to the volume in the second beaker. So this is just taking this entire process that I drew out and did step by step and putting it into one equation. But it's good to understand, where does that equation come from? Why am I doing this? Well, this is exactly what you're doing, okay? So we can easily just do some examples, and you'll see that it's not an overly difficult problem to solve when you're mixing solutions. And the nice part about this is this equation will never be rearranged. You'll only ever solve for final concentration. So it's kind of always going to be in this particular arrangement. Alrighty, so when 50 milliliters of a 0.5 mole per liter solution of sodium carbonate is mixed with 100 milliliters of a 0.25 mole per liter solution of sodium carbonate, what is the resulting concentration? Okay, so you always just want to double check, am I dealing with the same solute? Sodium carbonate and sodium carbonate. So we're good to go. We can use that formula. So I'm going to write C final equals C1 V1 plus C2 V2. So this is calculating number of moles divided by total volume, V1 plus V2. Now, I'm just going to go through and label. Again, it really doesn't matter what you decide is your C1 and V1 and what you decide is your C2 and V2, as long as they're paired correctly. So these guys go together. So let's call this C1 and let's call this V1. Now notice that's in milliliters. It's going to have to be in liters because our concentration's in moles per liter. And let's call this V2 and C2. Again, we're going to have to convert that, but we can do that in our heads because we've done it so many times. So I've got 0.5 moles per liter. Okay, so we're going to take the concentration times the volume. Now remember, we don't want 50 milliliters, we want 0.05 liters. Move my decimal place 3 spots. And I'm going to do the second set, so 0.25 moles per liter. times the volume. Instead of 100 milliliters, that's 0.1 liter. Whoop. And I'm going to add my two volumes together. So 0.05 plus 0.1. And then what I would do is I would multiply, and add. Okay, so on the top I'd end up getting 0.05 moles. And I'd add together these guys, and that would be 0.15 liters to get 0.33 moles per liter. Okay, so when I add these two solutions together, the resulting concentration is 0.33 moles per liter. So again, you'd expect it to be somewhere between 0.25 and 0.5. And if you look at your volumes, you've got 100 milliliters of the 0.25 and only 50 milliliters of the 0.5. So you can see the concentration falls a little closer to this concentration because you have more of that solution. Let's try a couple more. Okay, so I'm going to write out my, well, I don't need to write out the full formula again. So C final equals. So let's identify our variables. If a 250 milliliter solution of barium nitrate with a concentration of 1.5 moles per liter, so let's call this V1 and C1, is mixed with 500 milliliters, so that'll be V2 of a 0.75 mole per liter solution of barium nitrate, what's the final concentration? Again, be careful of your units here. They're in milliliters, so we want to convert that to liters before we calculate. Okay, so let's take our first concentration, multiply by our first volume, remember in liters, and we're going to add that to our second concentration times our second volume in liters, and then we want the total volume. So let's add our two volumes together, 0.25 plus 0.5. Okay, so again, you're going to make sure you do order of operations here. Multiply, and then add. Okay, so on the top, we've got 0.75 moles. And on the bottom, we would have 0.75 liters. So we'd get a final concentration of 1 mole per liter. Let's just make sure that makes sense. So our two concentrations are 1.5 moles per liter and 0.75 moles per liter. And you want to make sure your final concentration should be somewhere in between those two amounts, which it is. All right, here we go again. I think you'll get the hang of these pretty quickly, especially because there's really only one type of question you can be asked. There's not really any variations here. So we have two solutions of potassium iodide. The first one has a volume of 300 milliliters and a concentration of 0.5 moles per liter. And the second one has a volume of 1.2 liters and a concentration of 1.25 moles per liter. So we have one unit here we have to deal with. That's the first volume. So 0.5 moles per liter. And instead of 300 milliliters, that's 0.3 liters. And then for our second solution, we've got 1.25 moles per liter times 1.2 liters. And our total volume would be the 0.3 liters plus the 1.2 liters. So again, do your order of operations. You would get 1.65 moles on the top divided by 1.5 liters to get a concentration of 1.1 moles per liter. All right, last one. Let's see, this one might have, oh, here we go. We threw a little curveball in here. This is a dilution question. So you always just want to read the wording carefully and make sure you know what you're dealing with. So 500 milliliters of water is added. Okay, so whenever water is added, you know you're dealing with a dilution situation, right? Because that's how you dilute a solution, is you add water. So 500 milliliters of water is added to 350 milliliters of a 0.75 mole per liter solution of strontium chloride. What is the concentration of the diluted solution? So if you recall, this is your dilution formula, C1V1 equals C2V2. Okay, so what do we have here? Well, we have we could call this our C1 and our V1, right? This is the solution that we start with, 0.75 moles per liter, and we have this amount of it, 350 milliliters. We're adding 500 milliliters of water to it. So you have to be careful here. The 500 milliliters is not your V2, right? Because V2 represents the total volume of the diluted solution. This is instead how much volume of water you've added to your original volume. So you want to make sure you clarify that. So V2 is actually 350 milliliters plus the 500 milliliters of water that you just added, which is 850 milliliters or 0.85 liters. Okay, so this would be your V2, and we're looking for the concentration of that diluted solution. So we're looking for C2. So we've got for C1, 0.75 moles per liter. For V1, remember this needs to be in liters, 0.35 liters. C2 is what we're looking to find, and V2 is 0.85. Or you could have rearranged this first as well. So I'm going to divide by 0.85, divide by 0.85, and C2 would be equal to 0.309 moles per liter. Okay, let's make sure that makes sense. This is the diluted solution, so it should have a lower concentration. So we started with a 0.75 mole per liter concentration. Once it was diluted, it's down to 0.31 moles per liter. So that makes sense because we've added water, so it's more dilute. It's a weaker concentration. Okay, so what you can work on is, I believe it is concentration, dilution, and mixing worksheet number 2, and part 1 is all mixing questions.